to our next session. And yeah, back to Shelley. But not only Shelley. Now we have a presentation done by Shelley, by Lan, and by Longyu about how AI can be used in testing, especially in open source. And I think we have, let me check, all here available. So welcome, Shelley, Longyu, and Lan. Can you unmute you? And yeah, perfect. Hey, good
Yeah,
to see you.
hello.
Hello.
Hey,
This time
perfect.
I promise to be faster.
Oh, we're good. I think we're good in time.
That's right.
Perfect. Good. So yeah, I assume you introduce yourself in the session, so have fun. Thank you.
Thank you.
Thank
Thank
you.
you. Let me share my screen.
Wonderful. Yeah, and I'll start by saying welcome Lan and Longyu, who are been colleagues of mine for many years, and we've done a lot of fun things together, and I'm so thrilled to have been able to work with them over the past couple months on some of the stuff we're going to present today. So before we dive in, I guess we'll say, what is AQAvit? We talked about previously what the project hierarchy looks like. AQAvit is a sub-project under the overarching umbrella project of Adoptium, and it stands for Adoptium Quality Assurance Vitality. We intend to try to continue to raise the quality bar for OpenJDK distributions based on the work we're doing in this project, and to empower developers to have tools and approaches for testing their changes. And since the beginning of the project, we've run based on a manifesto or a set of criteria. And some of those criteria are that we want to be open and transparent in our work, that we want to have diverse and robust test suites. And important to this presentation, we need to continue to evolve and invest in our solutions, and we need to have metrics that show whether or not we're getting better or worse at finding defects and raising the quality bar. And we want a portable solution in the way we test OpenJDK distributions. And we want a reproducible set of tools and approaches. Essentially, in a one line, we want to make quality certain to happen under the activities of AQAvit. And when we break it out and step back, what are some of the test activities that happen for any kind of open source software project? Well, there's planning and designing of tests. There's the writing, the implementation of tests. Once you have a test written, there's the automation of an entire suite. Once you're landing on a node, you're actually executing the tests, and that's kind of separate from automation, in my opinion. When those tests execute, some of them may fail. You may get certain types of results that you have to triage. Based on that triage, you may say, okay, there's a problem in the test case, there's a problem because of infrastructure, or there's a problem because of product code. And it's the product code problem that we really want to flag and fix. But the other types of problems also cause us not to be able to have a clean automated run. So we may need to exclude tests. There's a cycle here that happens in this little section. And finally, reporting. Reporting is really important in that reports should be succinct and let the people reading the reports know what their next action should be. So on each one of these types of activities related to testing, there are questions that you have, like when you look at automation, how often should you run your automated pipelines? How easy is it to run? Is it portable? When you execute, how few test cases do you need to be able to find defects in code, or how fast can a test run? So there are all types of questions that we want to answer here. And one of the ways we do that in AQAvit, one of the ways we achieve our goals that are listed out in that manifesto is by participating in open source programs. AQAvit committers regularly participate in open source programs. We have always done. I think there are about 20 examples of us participating in programs over the past years. And we typically structure our proposals into two parts. We have a concrete part that says, this is a well-defined problem. We think we know how we want to achieve a solution. So there's a lot of framework and guidelines and guidance around that. But then we have a second part to our proposals, which is our researchy prototypey phase, which is we want to bring people into our project through these programs and allow them to achieve and feel successful on the concrete part, but also let them be a little more free to learn and look at some of the latest, greatest research and approaches and help us learn what those are, being our research and development arm, essentially, at AQAvit. And we think there are mutually beneficial outcomes from that. It introduces new contributors to open source projects. We get to advance new features at the project. Contributors gain experience and can point future employers to their open contributions. And for mentors, committers, we get that additional assistance from these research and development teams that join us, these contributors, and we gain valuable knowledge about latest, greatest stuff, and we gain leadership skills. So in the last couple months, we've participated in two open source programs. One of them is Semesters of Code. And for this program, students from Carnegie Mellon University from Qatar and Pittsburgh campuses joined us for 11 weeks. They get a course credit. And we had two projects at Adoptium, one around supply chain security and one around performance and benchmark testing under AQAvit. And so we're going to, in this presentation, talk about the test-related one because that's the focus of this presentation. For the other open source program we participated in is Google Summer of Code. Again, having contributors from around the globe. And in this case, instead of course credit, that program sponsors contributors. And for our essentially 3 projects that we had, these were marked as medium-sized term lengths. So varying slightly depending on the contributor, but we had Commit Hunter, Glitch Switcher, and Vit AI, and 4 different contributors helping move these proposals forward. All right. And I get to say AI, AIO. We're about to talk about how we used AI solutions, and I'm going to hand it over to my wonderful colleague Longyu to take over and talk a little bit about each of these projects.
Thanks, Shelley. Hello, everyone. So I will introduce how we leverage AI to make our AQAvit projects more intelligent and efficient. So we will talk about the design and the implementations of our AI solutions in the following 4 programs: the Perf Survey, Commit Hunter, Glitch Witcher, Vit AI. So I will go over them one by one. So for the first project of Perf Survey, in this program, we enabled the decoupled performance tests and enabled the automatically generate of performance jobs. And also, we can gather the performance measurement in JSON files on Jenkins and whereas display it in the TRSS. TRSS, it is test result summary service, which is an important layer in our AQAvit test framework. And also we explored the AI-driven strategies based on the historical data, like using the AI models to do the input selections. And also we used the data to run the performance tests only on the high impact scenarios. So due to the time limitations of this program. So for the AI solutions, we just did some prototype. So currently, we are still working on integrating the prototype into our test framework. So if we look at the two figures, for the left figure, that is the dashboard of TISS. So after we run the performance benchmarks, we will see that for the decouple Eclipse benchmark, we got a performance of 100.33%. And then for the decouple H2, we got 100.09%. And also we have the calculation of the statistics data, like the mean, the max, the mean, the median, the standard deviation, and the confidence intervals. And also on the right figure, you can see that is the JSON file we generated in the Jenkins. So without TISS, we can also get the view of those data in Jenkins. It shows the values we want to look at for the performance benchmark. And another project is Commit Hunter. So the purpose of this program is when we have a good build, the last successful good build and the current bad build, if we have multiple commits among those two shards, how do we find which commit caused the test failures? So we start with the phase one of rule-based approach. So we just do some string matching based on the failure message to say which commit message is related to the failures. And then after the first phase, we go to the next phase of using machine learning models. So we collect the data from OpenJ9 repos to identify the issues for the test failures. We collect the good shard, the bad shard, and then collect the commit information between those two shards. We got the commit titles, descriptions, and the patches. And then with all those informations, we used some large language models like the commercialized ChatGPT and the open source DeepSeek models to ask these models to analyze and determine which commit is most likely to cause the failures. So for this project, we have got it working in the prototype. So we are still trying to improve the integration with our AQAvit project. So for the glitch witcher project, the purpose of this project is to scan the code and PR to analyze which defects may be introduced. So for the approach one, we predict the faults based on the cached histories. So we use the bug spot to scan the repos, and then it is automatically integrated into the GitHub workflows. So when we run it against the Git repos, it will give us a prediction of which files we may cause the bugs, so we can add more tests for it. And we also explored the approach to the reconstruction error probability distribution. This is a published paper with open source code repos. So based on the code, we first developed the model to scan the C and the C++ files. We used the OpenJ9 repo as an example. And since we also have Java files, so we also developed the model tool to collect the information for the Java files. And then we found out the likelihood of introducing the defects in PR. So when we open a pull request, then we will scan the files that got changed in the pull request to say if it is if it is possible that it can cause test failures. So currently, this workflow, it works to any repos because the algorithm, it is universal. So what we are trying to improve is we are trying to get the algorithm more customized for our specific project to improve the performance and the precisions. So we have contacted the authors to further improve the performance of these solutions. So for the following part, I will pass it to my colleague Lan to introduce more about our AI project and our future plans. Thank you.
Thanks, Longyu. We have talked about the 3 projects that we have for Semester of Code and Google Summer of Code. For those projects, we purposely separated the concrete part and the research part. Because we have such a great contributors, and for this VIT AI project, we just directly dive into the AI. So just step back a little bit, look at the existing large language models that we have. They all are trained based on vast volumes of data using billions of parameters, so they'll be able to answer all kinds of user questions. However, it may not have a domain-specific knowledge. And what this RAG, retrieval augmented generation system, will allow us to do is to extend that already powerful capability of LLM with specific domain knowledge without needing to retrain the model. This is really cost-effective to improving LLM output for us. So we separated this project into 2 phases. Phase 1 will focus on the documentations, and phase 2 will focus on the code. We will process this store them into embeddings and store into vector database. So doing a query, what happens is the query will be sending together with the context chunks through similarity search to the LLM and be able to generate answers. Right now, we're in the phase 2. This project is still ongoing. So with all 4 projects introduced, let's now step back and look at what is our AI position. From a user point of view, user only needs to looking at the left side. Basically, the user interact with some sort of UI. UI to us is flexible. We can use Tumble UI, Copilot, or WCA. And then that's about it. And then behind the scene, however, what happens is this UI or central hub will be connect to LLM. At this, for us, it's model agnostic because we can switch to any model based on actually performance or which one is actually better. So whether we use ChatGPT or Granite or Gemini or Cloud, we can switch that. And then also we have our own model context protocol server, so MCP server. With that, we can plug in any tools. The tool can be AI agent, so it can be a small domain-specific models, fine-tuned models, or RAG, like VIT AI, we just talked about. We can also plug in any traditional integrations like database, Git repo, or existing APIs that we have. So our current focus is in this MCP server side, so that we can at any time plug in or remove any tools that we want, so that our answers to the user will be more accurate. Okay, challenges and lessons learned. So I think one of the challenges that we're facing throughout the projects is because it's the data, the training data, because those data are not really generated for AI. They may be like we have those data years ago. So getting them, it's really, really hard because they may not in the same format. And then cleaning them up is also pretty hard because it's hard to write a generic script to go through them. Lack of GPU resources is also a challenge for us. We had to use Google Colab free tier. This actually limited some of our project's progress. As committers, we have other priorities like releases, other features, so our time is limited. So we will on this project, even though those projects are really, really interesting. AI field is rapidly changing. I think everybody knows that. I think the good side for this is it really forces us, encourages us to learn. And then also, I think a common problem is that it's difficult to validate AI results. We don't know what kind of user input will be, and then as a result, we don't know what kind of output it will be. Maybe we will start to have tracking system, so we know what kind of questions are more common or what kind of use cases are more common, and then try to, reduce hallucination as much as possible. The last but not least, we need to start small. I think, and then in that way, then we can quickly adjust our directions as needed. That's for the retrospective. Because of the GPU resource problem, we are going to update our program plan to prioritize investment in innovation. This is a big thing in AQAvit. And then with the Vit AI, we do see the potential with RAG. So we may extrapolate RAG to a broader foundation level solution, because that will encourage better cross-project collaboration. We will definitely continue to participate in open source program to advance on our AI position. And last but not least, to stay vital. Okay, so thank you so much for being with us today. AI is moving really, really fast, but I think the real power comes from how we use them. It is about staying creative, adaptable in a world that becomes more and more automated. If you are interested in joining us in a journey, feel free to reach out, join us Slack, reach out to us from LinkedIn. Let's keep building, keep learning, and let's stay vital together. Thank you.